Hey there, Python programmers. Today we're going to continue talking about classes and delve into two new topics, inheritance and something called polymorphism. So we've spent a lot of time defining this cat class, but maybe we want to make a class that's similar to a cat. How about we want to make a tiger class? Well, tigers have colors and ages and names. Maybe tigers don't have toys, and tigers probably need to speak, and tigers need to change their age. So there's a lot of functionality we've already created for cats. If we need similar functionality in another class, we can inherit from a different class so that we don't have to write that code over. So let's start by making a tiger class today. Now, each class should have its own file. That is convention, not only in Python, but in most programming languages. So to start out, we will make a tiger.py file. And now we do need to, from our cat file, import our cat class. Let's go ahead and define our tiger class. Basically, all we have to do to set up this inheritance is pass in the parent cat class of cat as an argument or parameter to our tiger class. Cool. Now, we are going to still need to make an init method for our tiger class. Again, it needs to take in self and any other attributes we want a tiger to have. So color, age, name, and let's for a tiger also include something called teeth. Tigers certainly have teeth, and those maybe are a little more important than for regular cats. If we take a peek at our cat class, we've already set up color, age, and name. Why would we want to do it a second time? We can instead inherit that from our parent. We need to use the super keyword and invoke it. Basically, what this says is, hey, I want to get this from the parent. Because we're pulling this information in from the parent, we don't need self, but we do need to say what we want to get from our parent class. And name. Now, we can't inherit teeth from this parent because as we see, it does not exist there. So if we have any attributes like teeth that we want to set up in our child class, we do have to set them up just like we did before. And it's good practice to save it to what we would hope to be a private variable. Cool. Let's do one more thing because we can. Let's print self.speak. And then let's go ahead and create our first tiger. I'm going to call this tiger Tony. He needs to be a tiger invoked. I believe Tony is an orange tiger. He's a pretty old tiger. I believe he's 72. His name obviously is Tony. And let's say Tony has 30 teeth. Cool. If we go ahead and save this file, let's run Python tiger and let's see what happens. Whoa, we got some output here. Now, our first couple lines actually are coming from the parent. Whenever we go ahead and import a file like this, it reads the entire file and evaluates it. So this many cats and destructuring or tuple unpacking the many cats and printing blue did all happen right here. Let's go ahead and comment those out so we don't see them in the future. And again, let's give this a run. And now all we get is Tony says meow. Let's also just print Tony real quick. And let's see what we got here. So Tony says meow, and then we have a cat class named Tony. So what's happening there? Well, what happens when we try to print self.speak? There is no speak method in our tiger class, but this is the magical beauty of inheritance. It can look into the cat class for a speak method, and we certainly have a speak method in the cat class. So it went ahead and used that, and that's why Tony is saying meow. Again, not ideal. We probably do not want our tiger saying meow, but it does show how inheritance, we have access to all of these methods and any of the tributes we chose to pull in. pretty cool so far. We also see that when we print Tony, it printed cat class named Tony is an orange cat. So again, we do not have a repr or a string method in our tiger class, but our parent does have them. So just like with speak, the tiger class is able to reach up into its parent and look for methods and attributes there. Cool. Now, as we see, those methods maybe aren't doing exactly what we wanted to. We probably do not want Tony to say meow. We want him to say something more tiger-like. And when it comes to printing out a tiger class, we do not want to call it a cat class. So this is where that thing called polymorphism comes in. We can choose to override the methods from the parent by defining them in the child. Again, the order of how Python is going to look for and use methods is it's first going to look to see if it's in the class it's in. And again, what we saw is it didn't find it here, so it went to the parent. So if we want to change that behavior, we have to define a dunder repr, and we do not want it to be super because that would be using the same thing as our parent. So let's go ahead and make our own where it's going to be a tiger class. And then we can pull in our tiger's name. Let's go ahead and pull in the color as well. That makes sense. And we'll throw in. Now we're going to want to go ahead and make a string method as well. Again, don't want it to be super. That kind of defeats the point of overriding them. All right, let's save all. And now if we rerun, hey, look at what's happening. Instead of looking up to the parent for a repr or a dunder string, it found them right here inside of its own class structure and went ahead and used them instead. So again, that is exactly what polymorphism is, choosing to override the parents. Now note, we were able to use self.name. Again, we have getters and setters for our name right here, and those are in the parent, so we can still use them in the child. Now for our underscore color, again, remember, we never set an attribute or a getter and setter for color because we felt, hey, cat's colors shouldn't change that often. So that is why we had to use the underscore there. Let's go ahead and also define a brand new speak method because again, we do not want Tony saying meow. That doesn't feel very appropriate for it either. So we'll create our own speak method here. Again, this is now going to be an instance method, so we do need itself. And then, ooh, we can do something silly if self name equals Tony. Tony doesn't say roar. Tony says they're great. So we're going to need him to say that for us here. And we can do boom, boom. Now, we probably are only going to have a single tiger named Tony. So in the event that it's not Tony, let's throw in an else clause. And we'll just return something like, we could still do self.name says something tigery sounding like R-A-W, roar, for a tiger. And in order to test this, we should make another tiger, just again. So let's do Tigger. T-I-double-G-E-R, that spells Tigger. Tigger's pretty old too. I don't remember how exactly old. Oh, he's actually like 90. And again, these are when these fictional character tigers were created. And I don't know, Tigger doesn't have a ton of teeth. Let's say he's got 12. Let's give this one more run. And now Tony's saying they're great, and Tigger is saying rawr. So, hey, we've made a very functional tiger class. Again, inheriting what we can and what we want from our parent, but also being able to make choices of adding in new attributes. Again, taking the ones from the parent, and then either using the methods from the parent or choosing to overwrite those methods in our child class. Again, the big thing with polymorphism is the order of how Python looks for things. It's first going to look for attributes and methods in its own class, and if it doesn't find them, that's when we head up to our parent. Hope you enjoyed this class lecture and keep on programming. I will see you all soon.